Welcome to A Window on SAHMRI, where we take you inside South Australia's independent not-for-profit health and medical research institute. Each episode, we get to know the people driving our life-changing research, getting into what motivates them personally and how their work is delivering a brighter, healthier future for all.
Steve, what drew you to science as a younger man?
Well, if I go back far back in time, my mum was a scientist and she instilled this sort of interest into us. She was a scientist, then a science teacher. And she has a story of me as a kid saying, "Oh, what species of ice cream is this?" And that was probably a fair indication. But I just sort of loved, insects and dinosaurs and all of that growing up and archaeology. And yeah, as things evolved, at some point I thought I was going to go into medicine, but just didn't get through those pathways. But as soon as I did honours, I was like, oh, this is it. It's just so fantastic doing something new every day. I don't think any job in the world, apart from what scientists do, is, you can just do something completely new, be the first one in the world to do it. The ability as well to sort of help people, I think, is really important.
And what path did you follow?
So from school, I went straight into the University of Adelaide. I did my bachelor's in biomedical science. And, that degree was useful because in the third year, you really got a bit more hands-on with science. And I was like, oh, this is pretty good. And then went into honours from with the people I knew from that degree. Alison Gilbert was my honours supervisor, and she did virology. And we did quite a few interesting projects in her lab, which was really interesting. And that was sort of what solidified science in my mind, doing that honours. It was just, such a great experience, although hard work. I don't think any scientists are, lazy or not hardworking, but, that really drew me to science. And then I continued on with Tim Hughes, who's still at SAHMRI, and Bruce Lyons, who's now retired. And, did my PhD with them. Continued on doing postdocs up in Queensland, 2 different labs there. And then I returned back to SAHMRI in 2017, where I've been since.
And why did you go to Queensland and then come back?
Just to get a broader understanding of what science is going on in Australia. Adelaide's still relatively small. Back in the day, the IMVS was, it was actually a fantastic research institute. It was probably world leading at the time for doing the sort of clinical and technology interface that they were doing. And, as good as SAHMRI's been, I don't think they've quite replicated what the magic was at the IMVS. But when that dissolved, it was pretty clear that research was going to take a little bit of a back burner in South Australia. And at the same time, Queensland, it was just going up. So you just have to sort of follow where the interest is. And I got to work with some great researchers up there, learn a lot of skills, and then came back and could apply it to sort of my own line of research with David.
And how have you been able to grow being a part of SAHMRI and under David's guidance?
Well, David's very big on microbiome. I was quite fascinated by that as well. About the time that I was looking to leave Queensland, there were a few large studies in Science and Nature showing how much the microbiome influenced the cancer immunotherapies that were like the big breakthrough of around 2012. And from those studies, it was just clear to me that this is going to be a huge impact on the field. So David also had that understanding, although he's more looking in the context of infection and vaccines. So between us, we came up with I think, a very nice research plan where we're looking about how the microbiome influences efficacy of drugs, toxicity of drugs, also sort of like cancer-late effects. It affects a lot of people post-cancer treatment. And I think we've developed a really interesting project that's ongoing there at the moment.
And it just seems to grow and grow how much of an impact the microbiome has, not only in cancer, but in so many other areas of health, and it very much being the second brain. And I couldn't count the number of microbiome-related SAHMRI news stories that I've written.
Yep.
Can you summarize in layman's terms why the microbiome's so significant, especially in cancer?
It's really, as you say, it's a second brain. It's, not only a large biomass, your bacteria, your fungi, archaea, everything in your gut, but how they respond to the environmental cues. So, if you are eating a healthy diet, probably have a healthy microbiome that'll, mean that, your immune system and everything will function quite well. Whereas the converse, where you're eating a poor diet or, not exercising enough, in addition to the effects that's having on your body, it's also impacting your microbiome. So sort of having this double whammy effect. So it's really like this central organizer that we neglected up until probably about, 10, 15 years ago. And now it's so prominent in so many different fields, as you say. But I think it's still very much in its infancy. It looks quite simple. You say, oh, yeah, eat healthy and you have a healthy microbiome. But the sort of, interactions there and interactions between different bacteria and other bacteria and viruses and then the host, it's just so complex. It's going to be years until that's all untangled.
And cancer therapy has such a destructive effect on the microbiome. How do scientists such as yourself go about trying to repair that damage or think about how to protect the microbiome against that therapy?
Well, most institutes, most cancer patients now are given, specific eating guidelines, try and eat as healthy as you can. But we're interested, as you say, about repairing it post-treatment in this sort of like post-cancer treatment as a part of the recovery. It could be, there's really no interventional studies yet, but it could be, a combination of diet, exercise, probiotics, just the sort of standard healthy recoveries that you would expect. Or it could be something more targeted, like you have a stool sample stored, Biobank does FMTs in South Australia. You could store this pre-treatment or get it from a normal donor and try and restore that after treatment. It's, there's not the evidence there to say what you should do yet. So probably just general healthy guidelines are the best way forward in that area, I think.
What excites you most about the short to medium term relating to the microbiome and the potential for us to be able to improve health substantially relating to that?
I think what's interesting now is that sort of the whole field has switched from a observational. So the sort of studies like, oh, if you've got this bacteria or your microbiome's more diverse or something like that, you might be more inclined to respond, to now a real interventional component. So people are doing FMTs, they're doing probiotics, all of these interventions, and they're seeing clear indications that they are working and improving treatment outcomes. They're only in clinical trials at the moment, so there's no approved adjunct therapy. But when you're looking at a treatment that's going to cost $200,000 per patient, just tweaking the microbiome there early on or when treatment fails, it's just going to be a minuscule cost, but it could have clear outcomes and benefits to the patients.
And is this something that science has always suspected is significant, but we weren't at a level where we could do much with it?
People have suspected what you eat in your gut bacteria impacts your health for probably even going back thousands of years. There's old FMTs in Chinese medicine, which were yellow soup that was for dysentery, and that was freeze-dried, well, not freeze-dried, just dried out fecal samples that they prepare into a soup and give to the person, and it would help restore their microbiome and improve their health after they've had dysentery.
Not sure if they told them what they were doing before
they probably were. This is hundreds, thousands of years ago.
Had to do what you had to do.
Well, if it works, you're going to do it, aren't you? So.
But now we're at the point where that FMT can be, fecal matter transplant can be delivered in pill form.
Yep.
Or certainly Hannah Wardle, who's also at SAHMRI, is working on that and now trialing that with humans.
Yep.
Throughout your career, you go from being a researcher under a senior researcher to taking on more of a leadership role yourself. How have you gone with navigating that over your time as that's become more significant in what you do day to day?
It's certainly a challenge because I'm sure David would agree, but I'm not always doing paperwork is not my favorite thing to do. As most scientists who progress in the field, they love getting the lab, they love getting their hands dirty, they love that exploration.
Are there any scientists where paper is their favorite thing?
Bioinformaticians, they're on the computer all the time, and that's their bread and butter. And they're absolutely critical for research now. The amount of data that's generated is absolutely because I finished my PhD in 2009, and from then, RNA sequencing had just begun, and now we're doing single cell RNA sequencing, we're doing single cell ATAC, we're doing spatial sequencing, and the amount of data you generate is just mind-boggling, really.
Tell me a bit more about your supervisor roles and the challenge for you in leading students.
I think I'm always I like to be quite hands-on, and at some point you just got to let the students do their own thing with guidance. I've been fortunate to have some great students come through as honours and PhD students. 2 of them are finishing up this year, and hopefully go on to do their own things, because they're both going to be very good scientists in their own right. Yeah, and just guiding, I think, is the main thing. I like to. You can't just do the things for them. You got to sort of show them, watch them, and then let them do their own thing. So yeah.
And have you had supervisors throughout your career that have done that for you, that you think about trying to emulate the experience they gave you?
Yeah, well, I think when I started, I think because it wasn't a smaller scale, but it was a lot cheaper to do research back then. I talk about the sequencing is advancing, but like a single cell experiment might be $25,000-$30,000. You don't just give that to an honours student and hope for the best. Whereas back in our day, we were sort of given things and just hope that it would work out well. So when I was going through my PhD and honours, it was much more of a hands-off experience, sort of the old, here's the keys to the lab and come back in 6 months kind of experience. But I think that taught a lot in of itself. You'd had to work things out yourself and learn to talk to people that when you need things. And
having that freedom and needing to show ingenuity.
Yeah, absolutely.
Tell me about the challenging aspects of being a scientist. We were talking off camera about the difficulty with applying for grants, and as everyone can relate to, only being successful 10% of the time or less. How do you cope with disappointment or frustration and putting in a lot of work and then not necessarily getting the result that you're hoping for?
Well, I think you just need to celebrate the wins when you get them, because there's a lot of losses along the way as well. You have to have a very thick skin to be in science. But yeah, the funding situation is really challenging now. When I started my applying for grants back in 2009, the NHMRC project grants that are now sort of these ideas grants had a 23% success rate. And everyone was complaining at the time. They're like, this is untenable. And now that's dropped to 8.1% last year. That's a lot of scientists that are missing out. And they're really fantastic grants. When you read these and a reviewer, you just see how good research is in Australia and how little of it's actually getting funded. So
yeah, so many incredible ideas that aren't getting the time of day that they deserve because the funding's not there. Are there a lot more scientists putting grant applications forward now than there were 20 years ago, or there just isn't the funding there comparatively?
I wouldn't know the numbers, but I think, like I said, the research has just gotten more expensive. There's the cost of living crisis, but there's also the cost of science. Everything has gone up significantly in the last sort of like 5-6 years. And the amount of funding that's there has not changed. So we really just need that to go up with the cost of living, and I think that would be a huge step forward.
How does that impact your ability to be able to stay focused on your research and stay positive with your students?
It's more the time that you spend on these applications. If you have to put in multiple grants to multiple rounds, you can spend a third of your year applying for grants, and that's like a third of a year that you're not doing science, or maybe a third is a bit too much. But there's a significant portion of every scientist's year that's just applying for funding or reapplying grants you've put in before, and it's a lot of effort, a lot of polish that goes into a grant that then just doesn't quite make it. So if we didn't have that much demand on us to be getting funding, it would make everything else you do a lot easier.
What would you like to see happen in that regard?
There's a lot of funding tied up in the MRFF, that could be released, as far as my understanding is, and there's a bit of a push from ASMR. I think they're trying to push the government to just open that up and put it into IDEA's scheme, because the MRFF was set up.
There's billions of dollars there that's not being accessed.
Well, that funding, I think the idea is the interests and investments on the original amount that was put into the MRFF was what's going to be used to fund that scheme. But as far as I know, there's more in there and more money that can be spent that's not being spent. And honestly, just injecting that into, IDEA's, ARC, investigator grants would just be a huge first step, I think, because these MRFFs have these targeted calls, which are great to address health needs specifically. But at the same time, you could have the best grant in the world that no one wants to look at that year, and then you just have to put it in these ideas grants and go in with the 8% success rate that everyone else has.
What's some of those little wins recently, or highlights for you that you hold on to when times are tough?
Getting these students over the line and seeing their projects shape up. He came to us as a second-year student, and he stayed on and done honours, worked as an RA, and now is finishing up his PhD, and he's just going to be an incredible scientist. So it's good to see him progress. And Joyce, who's, I believe, has been on this podcast before. Yeah, Joyce is going to go on to do some great stuff as well. Her projects shaped up really well over the last year. So I think both of them finishing up will be great. And we're starting to get a lot of projects to completion. So hopefully they'll be all submitted and off this year.
Must be bittersweet when you have really good teammates who've learned a lot under your tutelage and done some really great work, but then it's time for them to move on, and you have to let them fly.
Yeah, I think we've got a number of students that are going to be finishing up this year that will definitely leave a big hole in the lab. But we've got new ones coming in. So, yeah.
And do you find your career to be all consuming, or do you carve out some mental space and time for other things that Steve wants to do?
Well, I don't have too much time for myself anymore. I got 2 young children and now a dog, a 4-month-old puppy.
Oh, nice. Puppies fun?
Puppies are fun. They're very biting. And
you thought 2 young children wasn't enough of a challenge and you needed to inject some more chaos.
Well, it was the old classic, we really want to get a puppy. We really want to get a puppy. And you're kind of like, you guys have to look after you, And then
we will.
And then I'm the one out
with it.
10 o'clock at night with the dog while everyone's sleeping.
Poor dad.
But he's a great little guy. He's brought a lot of energy into the household. But I really don't have all that much time to myself. Just love spending time with the family, I think, is the main thing. And that's my main thing to do when I'm not at work.
What's some things that your kids love doing with you?
They love swimming. They're both really good swimmers. Even though one of them's not even 2, she just goes in the water and absolutely loves it. That's
impressive. I used to be a swimming instructor, and there weren't many 2-year-olds who were happy being in the water.
Oh, she's fearless, the younger one. Just getting out and about, like taking them for walks in nature. We do a lot of play at home. My wife teaches at home, so a lot of the time I'm watching them on the weekends and just coming up with imaginative games with them. I think Bluey's been a good positive role model for positive parenting.
I hear all parents love Bluey.
Yeah.
And what does that give you, being able to come home to that environment and have that circuit breaker away from your stressful work life, obviously being able to have your family there?
Well, I think anyone with family would say that it's not like a stressless environment at home, especially early on. But, it makes it worthwhile. It's just great to see the girls when I come home. And, I do love the cricket. And I did get to go to the Ashes this year, which was fantastic. Went with a friend from SAHMRI, Duncan.
Very nice. Did you go to all 5 days?
We went for 1 day.
Okay. I'm glad you carved out at least 1 day for yourself there
in
a very busy year. And what are you optimistic about in the short to medium term to do with cancer and immunology in particular?
So I think what we're going to see in the next while is these fecal microbiome transplants with checkpoint inhibitors really coming forward as a positive intervention. That's my hope. There's a lot of targeted treatments, but it does seem like the very broad, just transplant a microbiome and you get a better response. Seems to be very positive, at least in phase 1.
What's that going to mean for people who in the past and currently don't have a solution?
Well, there's now trials, and one of them led by a collaborator of ours, where you can take microbiome from people that failed. You can take the microbiome from people that responded really well to checkpoint inhibitors, put them into someone that's failed them, and about 30% of those now start responding. This is a really positive result. That's sort of akin to adding another immunotherapy into a treatment, which comes with substantially increased cost as well as increased toxicity. And you can do that without any increased toxicity and a minimal cost compared to the cost of these drugs. I'm really, I like working on immune agonists, and there's one that was just published last year that they used an FC optimized CD40 agonist, and people that had failed all lines of treatment, immunotherapy or not. Again, only a phase 1, so there's no comparison of treatment, but they had complete remission in 20% of people with that drug, and that's just incredible. So the immune agonist field has been around longer than checkpoints, but nothing's ever gone past phase 3. Nothing's ever been approved, and this drug, if it continues on, I think will be a standout treatment going forward.
But there's obviously potential there to grow that percentage of people who benefit from it.
Yeah, well, 20% cure is still very high in someone that's failed all lines of treatment. So I think, if that goes on through phase 2s and phase 3s, that would be really promising.
Let's hope so. Thanks, Steve.
Thank you, Callum.
If you want to learn more about SAHMRI and the researchers working to build a brighter, healthier future for you and your family, head to samhri.org.au.